Welcome back, guys, to Java Space. Today we are beginning a new series on Spring AOP. AOP stands for Aspect Oriented Programming. But before I dive into the details of AOP, it's important that we try to compare it or contrast it with our old style of programming, because clearly AOP is a modern style of programming that we see rampant today. It comes in frameworks, in many applications. So OOP versus AOP. So OOP is a programming paradigm where everything centers around objects in the design of your applications. But AOP is a paradigm that deals with separation of concern, where you break code into separate, distinct areas or distinct functionality. And this code, you put it in one place. This functionality that we say we are breaking down is because it's not part of the code where it was put before. So in the olden days, before the arrival of this kind of programming, you find that you do not have separation of concern. You do not have single responsibility. You find that code is just scattered throughout the entire application. But today, with advancement of these coding programming languages, there is a way for us to break down this functionality into cohesive area. And this functionality is also known as concerns. And as I said, they cut across multiple areas. They are duplicated across multiple areas. And when we break that code down and we put functionality that performs a certain functionality, or we put code that performs a certain functionality together, and we do not mix it or we do not tangle it with other code, we are doing what we call modularization. So we break code and put it in separate modules. Code that deals with transaction management, it is put in its own section. Code that deals with logging is put in its own section. Code that deals with security is put in its own section. So you are increasing modularity because you don't want to tangle your code. You don't want to mix concern, where you have business logic mixing with code that doesn't actually belong there. Because as a business person or as a developer, all you have to be focused on with is to write your own business logic. Nothing more, nothing else. And that is how your code should be organized. So the main difference between AOP and OOP is that AOP focuses on separation of concerns, while OOP focuses on encapsulation of data and behavior into objects. That's the only difference that we have between these two. So OOP is mainly used to organize business logic, while OOP, as we mentioned, organizes non-functional features and put them in their own place to avoid tangling them or mixing them with your concern. And this code that is cutted, or this functionality that is called cross-cutting functionality or cross-cutting concern, You have transaction management, you have security everywhere in your code. So you don't want it to be scattered like that. You want to put it in one central place and then use it into different areas where it's needed. So this way you are decoupling your non-functional logic or non-functional code from your business logic. And this makes your code cleaner. Why? Because each concern now is in one place, as opposed to code just being scattered all over. And it becomes difficult to read, difficult to maintain, difficult to test, as we will see as we go on. Classes are cleaner since they only contain code for their primary concern. We don't want that in our code. We are, for instance, let's say you are, let's talk about transaction management in this example. You are transferring money from one account to another. So what you should do in your business logic is you take money, you subtract money from the first account, then you take that money and add it into the second account. You have transferred that money. But now, this whole process must be put in a transaction. Because now, let's say the first transaction, the first process passed, which is subtraction of money from the first account, which is in accounting, you are debiting that amount. Then in the second process where you are crediting it in the second account, that process produces an error. You see already the first process succeeded, the second didn't succeed. So in that case, you have to roll back, because the whole process must succeed for the whole process to be considered as complete, which is called in a transaction terminology atomicity. You have lost atomicity. But now, as a business or as a developer, you don't want to code that particular scenario where you have to roll back, because it's not part of the business logic. So you want to put that whole thing outside of that business logic. And by so doing, your code will be nice, clean, because you don't have to deal with that in that particular location. So now, we are not saying transaction management is bad. We are just saying, let's put it in the correct place where it belongs. Another advantage of this AOP is that you can write an advice, or you can write a code that cuts across multiple places in your application and apply it in a join point, which is a place where an advice gets applied, without you having to implement an interface, without you having to extend a class. And when you write code like that, your code becomes easy to maintain. Your code is less sensitive to changes, because now, you can change your interfaces, you can change your classes without having to come and do much changes on that particular advice. So AOP is not a replacement for OOP, but you can think of it as a more as an add-on that makes that code more cleaner, that makes your code loosely coupled, and in your code you are only focused on business logic, as I have said, not on things that do not pertain to what you are trying to solve. So these two concepts, or these two programming paradigms, they complement one another.